so let me introduce you another method. Do you remember we talked about this problem yesterday? So we had two lines L and L prime. We confirmed that these two lines are actually indeed skew parallel, and we were able to find this line segment, which actually lies on L and L prime and is perpendicular to both L and L prime, is called the common perpendicular of these two skew parallel lines. We were able to find its length, which is the shortest distance between the points on these lines from each other. And we also learned, Ruben proposed a method. We just continued that. We found an equation for this line as well. Yes, so that's completely correct, and it was working. But let me also introduce you another way to do that, and then we can go and solve some more problems. We end everything today here. So if you want to do this, another way is that because M lies on this line, the coordinates of M should somehow satisfy this equation, yes? So this means that if I put this equal to one parameter, say S, then x is s plus 2. So this means that M, the x coordinate of them, M which lies on L, should be s plus 2. And then when this expression is equal to s, I multiply, it becomes 2s, and I move 2 to the other side, it becomes 2s plus 2. And the same thing here, so it becomes minus 3s minus 1. So for some s that I don't know, yes, if I start varying this s in the set of real numbers, this M will start moving on this line, yes? But for one particular S, it becomes exactly this point, which I don't know which one is that. And then for the same reason, I can say something similar for N, but this time I choose another parameter. For example, let me choose a T. And then what happens is that N is minus 2T, and then Y is T plus 2, and then Z is T plus 4. Yes? So the point is that I don't know S, I don't know T. If I can fine-tune S and T in a way that this M is exactly this M and this N is exactly this N, then I can find the distance between them. Or if I want to, I can find an equation for the line on which N lies. Yes. So what can I do? I have two pieces of information, because you see, this is perpendicular, one piece of information. This is a perpendicular, another piece of information. So two pieces of information, two unknowns. Probably should be enough for me to solve it. Okay? So what I do, for example, let me just take NM. Vector NM is the final point minus the initial point. So this one minus that one. S plus 2 minus 2t becomes s plus 2t plus 2, yes? And then this one minus that one, 2's are cancelled, so this becomes 2s minus t. And then the subtraction between them, this one minus 3s minus t minus 5. So this is the vector NM. But I know that there is a dl here, and we already know what dl is. I told you that is just a sketch because I don't know the direction, I don't know the length, but I know that the vector dl somehow lies on this vector, because that's a canonical form. I just read the coordinates, the denominators, 1, 2, and minus 3, and then, so this is dl prime, which is what? Minus 2, 1, and 1. Okay, so I know that NM should be perpendicular to DL. So this means that the dot product DL dot NM is 0. But this is NM and that is DL. So if I dot product them, 1 should be multiplied by this expression. So this becomes S plus 2T plus 2. 2 should be multiplied by this, so it becomes plus 4s minus 2t, and minus 3 should be multiplied here, so it becomes 9s plus 3t plus 15. This should be equal to 0. Without going any further, let me simplify that, so this becomes 14s, yes, and then I have 2t and minus 2t cancelled, there is a 3t left here, Yes, and then I have 2 and 15, 17. I move it to the other side, it's minus 17. That's one equation. Yes, I do the same thing for the other one. So NM is perpendicular to DL prime. This means that DL prime dot NM is equal to 0. So what happens here is the dot product between these two should be 0, but DL prime is this one, so I multiply this again here. It becomes minus 2s minus 4t minus 4. I multiply 1 here, 2s minus t. I multiply 1 here, minus 3s minus t minus 5 should also be equal to 0. These 2s and 2s are gone, so I have minus 3s minus 4t minus t minus t minus 6t. And then I have minus 4 here and minus 5 here, minus 9. I move it to the other side, 9. And I divide by minus 3, yes? So this becomes s plus 2t is minus 3. Yes, so I have two equations. So I set up a system, 14s, and then I have 3t is equal to 17, and the other one is s plus 2t is equal to minus 3. If I want to solve that, for example, let me multiply this by minus 2, this one by 3. Then what happens, this becomes minus 28s, minus 6t is minus 34, and then it becomes 3s plus 6t is negative 9. So if I add them, this is gone. It becomes minus 25s is equal to what? Minus 40. 43. So that number is very... This I didn't expect because... Oh, I have made a mistake somewhere. Can you see that? Ah, this is minus. This is minus 17. Okay, so that becomes positive 34. So it becomes 25 now. So s becomes negative 1. Yes? The reason that I doubted, because it was more friendly numbers yesterday. Yes, so we will be in trouble if that's not the case here. Okay, s is minus 1. I put it here. I move it to the other side. T also becomes minus 1. Okay? And then when I know that s and t are minus 1 and minus 1, I can go back here and finally find m, n, and nm. Yes, whatever we want. So for example, let me calculate nm. So the vector nm here, I put minus 1 and minus 1 here, so it becomes minus 3 plus 2 is minus 1. I put it here, minus 2 plus 1, again minus 1. And I put it here, plus 3 plus 1 minus 5 is minus 1. This is my vector nm. First of all, as a byproduct, you can calculate the length, which is the square root of 3 again. So we actually can find that answer here. So if you follow this method, you not only find the length, but you can also find the equation for the line. So what can I do? For example, I put either I can calculate s, m, or n, and then I have my direction vector, because this would be the direction vector of this line. Yeah, so what I do, for example, let me calculate the coordinates of m. I put s equals to minus 1, 0, and 2, 2. Okay, and then I write an equation here. So equation, let me write the parametric form. So x is equal to minus 1. And by the way, when I want to write an equation, I can rescale it because that's direction vector. I can consider it 1, 1, 1. So it becomes t plus 1. Y becomes t plus 0. And z becomes just t plus 2. And t belongs to r. So that's an equation for this one. If you want, you can write the canonical form. You can write x minus 1 is y is equal to z minus 2. Yes, that's also possible. So anyway, we can actually solve that problem. But what I want you to, I don't know how do you think you can really draw this Mn in practice? So if you have two skew lines, first of all, how can you understand that such a line actually exists? For this case, this is the proof that this exists, yes? Because we were able to show that there is one line, and that's unique because you didn't get two answers for S and T. You got just one answer for S, one answer for T, and you got the answer. So it means not only for this particular problem you showed that such a line exists, but also you showed that such a line is unique. The existence comes from this fact that you were able to find ST, and the uniqueness comes from this fact that you couldn't find any numbers except -1 and -1 for S and T. So for this problem, I can say that I just proved both of them. But do you think this is in general true? So does it really depend on how these skew lines are located in a space? If not, you have to be able to convince yourself that is always the case, that I can draw the common perpendicular line for the skew lines, and that line is always unique. This is a good problem to think actually about. Okay, so what I mean is, can you give me a suggestion using these features of Geogebra so that we can really do that without calculations? We calculated actually. So for example, let me just punch these in. So the first line, which was D, the equation was x minus 2 equals to y minus 2 divided by, what was that, 2, yes, is equal to z plus 1 divided by -3. So that is your first line, okay? And then we go to the other one. Am I right? Yes. Yeah. I don't know. The Geogebra is actually probably doing this correctly. So, but then I will go to the other one. So x divided by -2, and then I have this one equals to y minus 2 equals to z minus 4. First of all, are they skew parallel really? So let us see. Yeah, they are, yes. These two lines are skew parallel, as you see, but the point is that you have all these features available. For example, you can draw a perpendicular line to a plane, you can draw a parallel line to another line. These things you can do, okay? And then here when you go, you can talk about plane through 3 points. You can talk about, I don't know, just a plane that passes through a point which is perpendicular to another line, and then 2 parallel planes, yes? So assume that you have these features available. Can you tell me what to do if you really want to find this? Now you see that that is not a very trivial fact. So you have to find a nice way to do it using these features. Or might be, I don't know, for example, I don't know why Geogebra doesn't have the plane including 2 intersecting lines. Might be you can also construct that from one of these, from a combination of these features. Okay, so the tools that you have in your hand are these tools, and then probably these tools, yes, which are relevant. Angle, bisector, tangents are probably not relevant, and of course you can also have these tools. Now tell me, using these tools only, how can I draw that perpendicular the common perpendicular line? And if you have any suggestions, you can just tell me. I will do it here for you, okay? I don't know, but what is the best angle to see? Might be, yeah. But you have a feeling what's going on now.
Robert,
Yes?
I think the intersection between the perpendicular planes of both lines is going to be the perpendicular line.
No, but tell me what to do, for example.
So take the perpendicular plane of both.
What is the meaning of perpendicular plane of both? Because I can't. Because if you
of
want, you need to find a
each one
point.
separately.
Pardon?
Of each one separately.
No, what is the meaning of perpendicular plane? Because if you say a line, I can have different perpendicular planes at different points on the line. Do you just mean randomly draw something, or you have something specific in mind?
No, I didn't think about that.
Yeah, okay. Yes?
So wait, what's the question? Find the line or find the...
No, find the line. I want you to draw the line.
Okay. If you cross product the direction vectors.
No, there is no cross product. What I'm saying is that using these features of Geogebra, draw that line. No, these features that I mentioned, not cross product. Cross product brings calculation in.
Okay.
Like we did it with calculation. We don't need to do it once more.
Okay. Can I look at the features still?
Yes, the features are these ones. And then probably these ones. I don't think others are relevant. Might be, of course, you can also draw spheres if you want to, pyramids. Yeah, but... And by the way, reflection about a plane. I don't think... I mean, these are probably relevant.
Existerar 360 miljoner stycken i mig. Så ja, okej.
So let me pause recording, you can think. So I think it would be good if you can see here, you know. So let me have this one. I don't know, this is not a good representative of a line. So for example, this is one of your lines, and then you have another line here, yes? Of course, how do you think you can do? For example, you cannot say that I draw a perpendicular line to this point, because there are infinitely many. But if you want, you can say that I pick a random point and I draw a perpendicular plane to the line at that point. This is reasonable. This is one of those features you can use. So now, this is what you want to do. Okay, do you have any suggestions here? And if you find something here, then we go to Geogebra and try to do it, yes? So you have the feeling that this line from here to here, yes, is the common perpendicular line. So how do you reach to that if you want to draw it? By the way, if you see, if you want to do it exactly, it's not that trivial, yes? Because, for example, you have a feeling where it should be, but if you want to do it 100% precise, then it is not that easy. Yes. You want to find a location with 100% accuracy. Do you have any idea what to do? Yes. Okay, so this is a good way to imagine, because I think in Geogebra the lines are in a way that it is a little bit distracting. So you can think about this feature, or you can also play with your pens and pencils to see how it works. Is there anyone doesn't have any problems to be in front of camera? Because I need the help to show you how you can do it. Yes? Yes, Dima, you can just here. Because unfortunately this table is not in the, so you can keep this one. Yes, that's good. And then I have this, okay? So what I'm telling you is that you take a random point here. Is it in the camera? Yes. A random point here. And then from this random point, which is a point, and this is a line, you can draw a parallel line to this line. Yes? It's possible, because whenever you have a line and a point outside the line, you can always find exactly one line which passes through the point and is parallel to this one. So this becomes something like this, yes? If I want to show you, so it becomes something like this. Do you think it will help somehow? Then this line and the original line make a plane for you. Yes? Okay, then what? Yeah, so you were doing the same thing?
Kind of.
Okay. Okay, so you are on the right track. Now what we are supposed to do? So at least it is helping, yes? Okay, so let us think a little, because you were on the track, and then try to find that how this will help. Of course, that is why I told you that unfortunately I don't know why Geogebra doesn't have this feature, but you don't know, so you can, if you have this line, and you have a point and you have another line, I don't know, this should also be a standard feature in Geogebra, but it is not there. So you cannot ask Geogebra to draw the plane containing these two lines, but you can ask Geogebra, if you saw the features, you can ask Geogebra to find the plane that passes through 3 points. So one point is your random choice here. You choose another random point here, another random point here. Sorry, so we need 3, yes? Okay, because I have it here. I already drew this parallel to that line. So I have this line, I have this line, and I have this point. So I can take one point here, and ask Geogebra to draw this plane for me. That is also one standard one, so you really don't need to, so you can always talk about the plane containing 2 intersecting lines, even though that is, I don't know why it's not a feature in Geogebra, but it's always doable based on this one. Because Geogebra tells you that, okay, if you have that feature, you can also cover this. Yes? So you have this plane, okay? And then you have still your line above here. And then one more step. What is the next step? Dima, can you come once more here? Okay, can you keep these two now? This was the line. This was the original line. This was the original line, and this one I drew parallel to this one. Yes, and now we realize that we can have a plane here, and then we can have a perpendicular line to this plane, not to this line, because then I can have a perpendicular line here. It goes up to the ceiling. Okay, but then you can take that one and move it here so that they intersect. Yes, that is your line. It's clear in this. But in this setup, you have to find the correct feature so that you can do it using Geogebra. So you can ask Geogebra to draw a perpendicular line to this plane. That was one of the features. So you have this line. But this line will not intersect this one, unfortunately. So then you need to find a good feature so that how can I move this one here and make this intersection using only those groups of features. Yes? Yeah, thank you. And then again, you need to think about another plane. Yes? That's it, more or less, the problem is solved. Think about another plane, then the problem is solved. Okay, so let us see what we have on the board, and then probably you can find, because I think it's now simple for you, yes? So, but of course it's hard for me to draw the correct picture. So if this is your L, and let us consider this to be L prime somewhere. Okay, so for the time being, we don't know where exactly M and N are, but this is L prime. So what we're supposed to do, we learned that I take a random point here somewhere, okay, for example here. So I don't know exact point, so I have to take a random point here. So let me call it A. And then we learn that I draw a parallel line from this point parallel to this one. Yes, this is doable. Yes, so I draw this one. Yes, of course it goes here. So this is L double prime, but this L double prime passes through this random point A on the line L prime and parallel to this one. This is possible always, and that is unique by Euclidean geometry. Yes, that's a parallel axiom. Okay, and then these two lines will make just one single plane for me. It's hard to draw it very nicely on the board, but let us have this one. We don't have any problems with this plane, yes, because this is my random point. Then when I have this L double prime, I choose another random point here, another random point here. So then I will have 3 points that I can draw this line. And then what happens is I can draw a line perpendicular to this plane that passes through this one, yes. It's hard to see it. I don't know how to draw it exactly. Might be this is not a good way. Yeah, I don't know how to draw it, but what I'm saying is that, can you see that plane now? Yeah, might be the other way around in this picture is easier. So if you don't mind, let me just clean this and do it the other way around. I don't know if I can succeed eventually to do that, but L, and then this is L prime. Yes, this is my L prime from the beginning. Let me choose a point here. It's easier to draw, I think. I don't know why for me. So I choose a random point on one of them, say this time L, and I draw a parallel line to this one. Yes. And then these two will make a plane for me. Yes. And then I take this one and draw a perpendicular line. But of course, there is no guarantee that they are intersecting. Might be they are passing through each other without intersecting. Okay, then what I can do, I can take this line and that line. This will make a plane for me. Yes? But this plane definitely will intersect L prime, but not exactly at that point. So wherever it intersects, then I just connect these two intersection points together. It's a really, really bad picture. I don't know even how to draw it so that you can understand. Because the way that I have drawn it here, it seems that this is the intersecting point. We don't have any problems with that. But what I'm saying is that if that is the intersection point, you just need to connect them, okay? I don't know, is that clear? Yes, so can you come again here, please? Might be it is easier to describe it here. Okay, so let us, so we learned how to do it up to here, so just keep these two. And then I have this line parallel here, yes? So I draw a line perpendicular to this plane here. And then this line and this line have a plane, yes? And this plane will definitely go and cut this. Whenever you have that one, you take that point and draw a parallel line to this one, it will intersect this one exactly at perpendicular angle. Is that understandable? So this line, now this line and this line make a plane for me, and this plane will go and intersect this at some point. Then I have a point here, and I have a line here. I can draw a parallel line from this point to this line. But of course, you have to convince yourself that it really intersects this one now, yes, and it is perpendicular to both of them. This is the method, but of course we have to defend why this method works. Intuitively, I hope that you agree it works. But let us check and then try to convince ourselves that this is really the case. So now, I will go to GeoGebra. Do you remember the process? So let us use this process and don't get confused, okay? Okay, so now do you remember what I'm supposed to do? I don't know which line we're working with. I don't have any clue which one might be better. Yeah, but if you don't mind, let us work with this line that you see here. What I'm supposed to do you remember? I pick a random point on this line. So I go here, I just take a random point wherever I want to. That's my point. And then I ask GeoGebra to draw a line passing through A, but perpendicular to this, parallel to this line. So I go to this feature, parallel lines. So I will choose this point and I will choose this line. The GeoGebra draws that black line for me. So this black line is parallel to this line. Then, do you remember what I'm supposed to do? You can practice. What I'm supposed to do now, I'm supposed to draw that plane. So what should I do? GeoGebra only unfortunately has this feature. So I have to have 3 points. One point is A. Then I pick 2 more random points. One here, for example. One there. Do you agree? And now I ask GeoGebra to draw the plane that passes through these 3 points. And that is possible. So I go here and I will use this feature. It becomes probably complicated. Don't look at it for the time being. So we have to look at it from different perspectives. If you want, we can rotate it a little bit so that what we have sound. This is what we have so far, yes? I don't know, what is that plane passing through C or no? Yes. It's really, I don't know, I cannot see it is really passing through C, but anyway, we didn't do any mistakes here. Okay, so now what was the other part, do you remember? Now what I'm supposed to do? I am supposed to draw another line which passes through this intersection point A, but now is perpendicular to the plane that I just drew, yes? So what I can go here, perpendicular plane. So what is, there is no perpendicular line.
I think it was another one.
Here? Yeah. Here, perpendicular, thank you. So I will go and ask GeoGebra, this is the point, and this is the plane. And now you have that line. Yes? And now what I'm supposed to do, let me move this a little bit so that you can see better. Okay, here we have this situation. Do you remember what I'm supposed to do now? I have to draw another plane which contains this line that I just drew and the original line. Yes? So, but I cannot do this using GeoGebra, so what I do, I take this random point here, then I have D, A, and B is already there. So what I do, I will go and ask GeoGebra to draw the plane that passes through these 3 points. Yes? And then I get another plane. But then I have to go and ask GeoGebra to find the intersection between this plane that I just drew with the original line that I didn't do anything with it so far. So I will go and ask GeoGebra to find the intersection. Hopefully I can do that. This plane and this line. I got point E. Is that right? Okay, now what I'm supposed to do, draw another line that passes through E but parallel to this black perpendicular line, yes? Let us see what it goes, how it goes. This is my understanding. I hope that it works. I have to go to what? Parallel line again. Where was parallel lines? Here. So I just asked GeoGebra to do this with that. Yes? And I don't know, do you think they are intersecting now? If our theory is correct, they should be intersecting. So let me ask GeoGebra to find the intersection point of what and what. This black line, and then this original line, if I can show it. No. Oh, I was on the wrong feature, so I hope that we are not losing everything. Okay, so I have to go to GeoGebra. So let me see it from a different view, but don't get confused. But they are not intersecting, are they? I have to find the intersection. So what happens? Okay, I have to draw a line from E parallel to this black line, solid black line here. So that was correct. So I take this one again. I take this point. I missed that part again, so I have to repeat. This is the line. And then I have to go to intersection and find this line here with this line here, if I can click exactly on it. And then I have an intersection point. Otherwise, Geogebra will not answer that, yes? Okay, so this means that I don't know from which perspective I can show you that you can see better. Yes? So you see that that is the line, yes? This line EF is actually the line. So let me just get rid. I don't know, can you see that? Yes? Hopefully it is visible. So that EF is exactly the line that I was looking for. Yes? And by the way, let me ask Geogebra to calculate the length of EF. We already know the answer. What is the answer? Length of segment. Yeah, so that's also a little bit nice programming language. Yeah? Point E and F. Yes? Is that right? So what do you expect to get? It's square root of 3. 1.7 something. Yes? And then hopefully Geogebra, by the way, knows about the answer. So what was this? I don't know which one is this line. Yes, this line. And then Geogebra has found the answer. By the way, why do you think Geogebra writes the answer like this, an equation of a line? It's 102 plus lambda times these numbers. Yes? I don't know how Geogebra calculates, but I want you to understand that is another way of saying the equation of a line. Because lambda plays the role of your parameter. I use t usually. And then if you go to my equation, do you have my equation for this? What was that? X equals to what? First of all, this is playing the role of the direction vector. And I can rescale it. All these three numbers are the same, so I can divide them by this nasty number. It becomes 1, 1, 1. Yes? And then it becomes lambda plus 1. The other one becomes lambda plus 0. The other one becomes lambda plus 2. And that's the same equation that I got, but instead of lambda, I had t. Yes? So actually, that's also something. So it was complicated. If you really wanted to use these features, this is the way that you have to do it. By the way, you have to convince yourself this works all the time. So there are some things I want you to think if you are interested. Why, for example, this plane and that line definitely intersect? Why these lines are really perpendicular to the lines? So you need to convince yourself that this is indeed the case. But this is the way that we draw it, but you have to defend why this method works. Yes? That's also another feature, why this method works. Yes? If you really want, you can also think about it. Okay? Any questions here? But now it's understandable. If you want to do just a simple thing that you intuitively think is very clear, it's not that clear. By the way, if you want to really do it in practice for some reason, for example, if you want to do some constructions for a building or something, you cannot just rely, okay, we do this intuitively. If it doesn't work, you have to do it precisely. Okay, and this is more or less the way that you do it. Okay, so that's good. At least we brought this up. And more or less everything that I needed I've covered, but of course there are some problems we can still think a little bit, or that was not working. But let me just write one problem for you to see how, if I can find the problem. It seemed to be a good problem here. Yes. The question is this. I give you the coordinates. So the lesson is more or less finished. Okay, so that's just another problem in the same topic. So I give you 3 points. A with coordinates 2, 0, and 0. I want to copy and paste the numbers because if you get the answer, I should be able to check it immediately. So 0, this one. These are points, not vectors, of course. And then I have 2, 4, and 0. Of course, it makes a triangle. My question is that find an equation for the line containing the angle bisector of the angle A. What does it mean? It means that, for example, this is just a sketch of this situation. I don't know what happens actually if I draw it perfectly fine. But what I'm saying is that this is a triangle. There is an angle bisector between these two lines. So if you draw that so that it becomes two equal pieces, alpha and alpha, my question is that find an equation for AD. Yeah, that is a little, you have to be creative in this regard. So you have to remember something we covered with vectors long back actually. Okay, but you want to find an equation for this angle bisector. So you know that you need a point, which you already have, but you also need a direction vector. Finding a direction vector is problematic here. So you have to be creative to be able to find that direction vector. Okay, so I want to think a little bit to see how it goes. Okay, any ideas? Because we are getting close to the end, I want to solve this problem so that everything is finalized. So any ideas how to find? So let me remind you of something. This is very long time back, you know. So if I give you two vectors, forget about this problem momentarily. So this is vector A and this is vector B. If you want to draw a vector that bisects the angle, what do you do? No, because if you add these two vectors, in this case, you usually use the parallelogram. Do you remember? Let me mention this before. So you draw a parallelogram and then draw this diagonal. But this diagonal, in a real parallelogram, there is no guarantee that this diagonal bisects the angle. Yes? But unless this is a very special parallelogram. In one case, if I have something to say about this vector and that vector, this parallelogram becomes a special parallelogram, and in that particular parallelogram, the diagonal bisects the angle. A rhombus, yes? So we have to make it a rhombus. I mean, and you cannot make it a rhombus, of course, because there is no guarantee that this vector and that vector are equal in size. But there is a famous vector equal in size lying one here, one there, and that's the unit vector on them, yes? So this means that if I make this vector a unit vector, which I know how to do it in principle, so this is the unit vector on A, and if I do the unit vector on B, yes? Then if I do the same thing, if I construct this parallelogram, this time the parallelogram becomes a rhombus. And if I just add EA to EB, then this becomes EA plus EB. And because this is the diagonal of a rhombus, it will bisect the angle between these two red ones. But of course the angle between these two red ones is exactly equal to the angle between the black ones. So this is the point. Yes? So now I think you understand. We had this before, if you remember, very long time back. So if I want to do, and it's extremely important, by the way. So let me just, so here in this picture, it is extremely important to draw AB and AC, not the other way around. Because if you just write BA, then you will get another angle bisector, which is outside the triangle. So you have to respect this order here. So I will draw AB. AB is the final point minus the initial point, which is 4, 0, and 3. And then I will have AC, which is what? The final point minus the initial point, 0, 4, and 0. Agree? Am I right? Yes. And then I find so from here, how can I find this unit vector? Do you remember? I have to divide the vector by its length. Yes? But what is the length of this vector? The length of this vector is 16 plus 0 plus 9 square root, which is 5. So I divide everything by 5, so it becomes 4 over 5, 0, 3 over 5. Yes? And then I divide this by its length, but the length of this is 0 plus 16 plus 0 square root, which is 4, so I divide everything by 4. It becomes this, and it becomes 0, 1, and 0. Yes? And then what I need to do, I need to add these two vectors, EAB plus EAC. If I add them, it becomes 4 over 5, 1, and 3 over 5. And this is the vector which is the perpendicular, this the angle bisector. But can I rescale it now? Yes, I can rescale it now, but not before. Because if I rescale it, it becomes 4, 5, and 3. It would be along the same direction. If it's along the same direction, it is still angle bisector. And then what can I do? I have my point here, and I have the direction vector. This will play the role of the direction vector of that one. For example, I can write a parametric form for that line, yes? So these numbers are supposed to be the coefficients of the parameter t, so 4t, 5t, and 3t. And then those coordinates should be added here, so plus 2, plus 0, plus 0, t belongs to r. So that is one form of an equation for that line. So you see the calculation was simple, but I mean that you have to have this idea. Okay? Yes, so I think everything is more or less finalized, so we can stop here then. This lesson is completely finalized. Thank you. Any questions, by the way? Here? No? Thank you.
Good one.